We're going to start presentations in a minute. And are you running there, or you want to?
I think so. I just want you to double check something.
Paul, do you know how
Hold on
to,
1 sec.
Paul, do you know how to turn on the projector? Is there,
No, sorry.
you're a substitute tutor, man.
Okay, I can help you with it.
Oh, there's remotes behind you.
Look for remotes.
So just a couple of things for while you're here. So there's, if I can just have your attention for a minute, folks. So the bathrooms are, just through the hallway there. They're just through the hallway and to the right. It also says that up there. The Wi-Fi details are up there if you want to get online, although that'll be especially useful later on in the evening at 8 after the presentations. And if you're here for the weekend or even just want to get tuned in and follow along with what's happening during the weekend, we've got a chat channel on our chat server, which the URL to get signed into that is up there. And Greg, you wanted to say something about media?
Oh yeah, is there anybody in the room who does not want to be photographed? Because I might be going around just with my iPhone taking pictures, and I just want to respect everybody's privacy.
Cool.
Thank you.
Are there any other logistical questions before presentations start? Yeah?
Is there any water?
Yes. Yes, so around the corner. Okay, well, also, first of all, obviously we're in the Anaconda offices here. So we're really appreciative of having that space. Obviously, we should also be very careful to respect it. And around the corner is some snacks and drinks in the kitchen space over there. Yeah, just be really mindful to kind of clean up after yourselves, and there's a couple of meeting rooms which we're able to use. The meeting rooms have band names on them. Generally, don't go into any rooms that aren't like meeting rooms.
So specifically, they don't have first names on them because the band names are not super clear sometimes.
Right. It's kind of obvious which ones are meeting rooms and which ones are offices. Don't go into the office rooms. Anything else, Jared?
We have one more person.
Would you like to introduce yourself or just get
Sure.
started?
Hi, I'm Chris Fronda, full stack software developer, Ethereum developer, blockchain developer. Interested to see what Holochain is going to do.
Awesome. We can find you a chair.
I'm good at those.
All right, so we're gonna put the live stream together, and Arthur and Matthew are both gonna do aspects of the presentation.
Do you know if there's an HDMI input or something else? Like we're plugged in, but it's not reading the.
Can we look at
Not getting a signal.
Yeah.
Yes.
We had
Oh, that's to the.
yeah,
That's just Ethernet. We're not supposed to plug it Ethernet.
oh, where's that board, the panel thing? This thing share. PC should say connected, but it's not saying. If you can give us like 2 minutes to just be able to get the computers plugged in to the presentation.
Never happens for live demos here.
Ever.
So I had it working fine, but I don't know when the voltage works so far. Something happened that way over the center.
Because the thing is,
Well, we can check underneath.
I would love to have. I can imagine a reading system that also measure your body, so you'll you're reading something that's regular.
But you guys,
How do you get feedback? Bias.
How do you select people for the program? How do you find them?
I have no idea.
I think it might be coming up.
Must be what?
Hit search.
So what about the HDMI?
I have an HDMI port. We've got an HDMI I have the remote.
Can I fiddle with the inputs?
Yes.
Right here. So
Let me go get the AV guy.
here's an HDMI. Here's an HDMI connection to here. So let's see what that's supposed to.
Art and Matt, can you describe the problem so Paul can ask the people?
No signal.
No signal.
That's not fully plugged. So we're trying to use this. We could also use HDMI, but we're not sure how to get the projector on. Gotcha.
It's in the middle of the table over here.
I can't believe that we're in a room full of geeks and that it's not already. So I'm just trying to. I'm not trying to take it out. I'm trying to make it so that it's clear.
We could try seeing if you plug this into the side of your computer. Just bring your computer closer and see if is it still searching?
Flip it over, flip it.
Sorry.
I'm doing it.
Hit search.
Try a different computer.
Hit search. No, we did not.
Because that was the problem. Oh, we tried multiple computers.
Do you have a computer?
I have my computer. We did not test it. We did try it. We used this dongle, the one with lightning. So we can just try mine.
Let's just, he's gonna. I've got it plugged into this one. So it should be, but do we have it on the right
He has it plugged in, but it's not working.
We're not making new apps, we're looking at, we make that kind of new algorithms for Holochain stuff that really
Yeah,
like how patterns and like something like it's like dealing with the big data itself. It's a super hard problem. We know we did it bigger than astronomy. Sometimes we just, AWS. Hang on. So there might be a TV, but there are other places AWS with this. Actually, that was really cool. So, AWS has all they use for data. It's called but yours is XML file that defines every single service that Amazon defines. And it's like, REST, various things kind of like REST. But the point is, like you can code generate against that, you can generate a client against for any language into AWS products. You can also do the inverse. You actually reverse engineer the server side. And basically have a AWS like API that's like exactly. So someone's doing that with blockchain. And also Amazon is downloading themselves. Their own API is essentially. That was a cool idea. I happen to know that API really well, so I had to write a client. I don't know. I just don't know. I don't know what the rules are for the company. There's no gym. I mean, everything's fine. I just don't know what the guys are doing. I mean, like, replacing S3, I think a really smart Holochain developer probably do this. Yeah, I mean, it's really, it's nothing else.
Fair enough. That's fine.
S3 alone, I think the state API is
Whatever he's saying.
Cool.
The guy to connect the box down there is this guy, the guy in the green shirt, Tucker. So we're just
Where did, so I pulled a black marker out of here, a black expo. Do we know where that just went? It was like sitting.
Nope. Should I bring people? You ready, Art?
We're gonna bring another projector up.
Art's gonna maybe go first.
We haven't got the projector working again yet. So we are going to let So if we can bring it to
You're aware of the long run thing, right?
Yeah. This is
wolfing, get wolfing.
Get wolfing. It's a little easier than this because people think that somebody's just raising their hand to speak. Right? This is like, okay, we're being.
In Texas, we call this Silken Horns.
Yeah.
Greg, do you want to, I think we're just going to kind of do it from this angle over here. So while some troubleshooting is happening with the projector, we're going to start the presentations anyways. And this gentleman is going to go set up with an alternative. Yeah. So Art is madly diagramming because he would be otherwise using visuals from the website. But I think, is that good, Art?
It's good enough. I don't know that any of you way down at that end can see it, but you can see it well enough? All right. So we're going to switch orders, and when we get stuff working for Matthew's presentation, we'll do that afterwards. what I'm interested in doing is kind of a technical introduction to Holochain. Hopefully not too technical for those that are not coders, but kind of starting at a higher level and slowly working our way down such that we could actually be building on it this weekend. And the basic components of Holochain, actually, let me start off differently. If you think about the game of poker, for example, you could define the game of poker from the perspective of a stack of cards, right? That you need these types of cards, this number of cards of these types of these suits and these denominations, and then you randomize the order and you cut that, and then you take the top card and you put them into sub-stacks, and then you can perform transformation operations on those stacks. You know, in terms of like turning, I'm playing draw poker here at the moment, not like Texas Hold'em as an example. And so you can turn in, you know, different cards from those stacks. And so that would be one way that you could sort of define the rules of poker. Another way that you could do it is from the vantage points of the humans, from the vantage point of the agents, the dealer and the players. Right, and so in this case, you have some operations that the dealer does. They shuffle to randomize the deck. You know, you cut, you deal hands. Then when people, our players are holding their hands, they can turn in a certain number of cards, that kind of stuff. You could probably, in fact, have two people that have different definitions of the game, one card-centric and one agent-centric, play together and pretty much have the same game, not really knowing they're playing by different rules. But there are some differences. And like, for example, if you don't define agents as part of the mix, if you don't define players as part of the mix, you can't really address things like table talk. You know, like you actually have to have humans in the equation to make rules about table talk, right? There's just a level jump there. If your definition is all about cards, can't really talk about table talk then, right? So obviously, hopefully this is obvious to everyone, this is a metaphor for the frame of reference difference between blockchain and holochain. Blockchain is what we call data-centric or token-centric, and Holochain is what we call agent-centric. And I say we because this isn't like some broadly understood nomenclature out there. We call it agent-centric because we actually define the rules and operations and transformations from the vantage point of each agent. And if you think about it, and first of all, we should just say, like David mentioned earlier, Scepter, which is kind of a grandfather project of Holochain, if you will. Holochain is a small part of this other crazy project that we've been building, where we are kind of rebuilding the whole computing stack from the perspective of living systems. Like, how is it that nature scales and does the things that nature does? And just for the inverse of the energy in the room at the moment, it's called Scepter because it's based on receptors. It's fractal receptors. It's actually built around the receptive capacity. You could say that Scepter is the feminine rebuild of masculine computing in some ways, right? It wasn't actually that we set out to build it that way. It's just, it turns out that it works really well. In particular, what it works well for is composability. The flexibility and composability instead of kind of the rigidity and fragility that happens right now in systems, like when you change something in your API and suddenly all of the people that are used to interfacing with you aren't interfacing with you properly anymore, and you know, it's very, very brittle connections in that space. So receptors are agents. Receptors are like mini virtual machines that actually can transform things. And so that's part of how this whole model carried over into Holochain. So what this is here, we should draw some other lines here. This is the the vantage point of an agent. So the agent has their, and I meant to do the local chain in a different color. An agent has their local chain and an interface to the DHT. And just to be clear, the local chain only holds changes that they made. Just like your hand in poker only holds the cards that you were dealt. Doesn't have the other cards in your hand, right? So the changes that the state changes you're making to the system are recorded to your local hash chain. So it's not a blockchain, it's just the regular old hash chain where you put in entries of data, we have little headers with hashes, linking it all together. And part of the purpose of this kind of data structure is immutability. So that once you've chained things together like this, you can't go back and change something without breaking all of the successive hashes. Everybody's clear about that kind of thing, right? And the thing, part of what makes it immutable is the fact that things get published to the DHT. Once these headers are published to the DHT, you can't change them without being detected that you changed them and that the hashes have been altered. That part clear? Cool. So then the second part is the DHT, which, again, not everybody has the same level. So this is your local chain. Source chain is mostly what we call it, actually, because it is the source of data that comes here. No data is in the DHT at all that wasn't written to somebody's source chain. And sorry, let's back up. DHT. So, yeah, exactly. Distributed hash table. So a hash table, actually back up, a cryptographic hash is kind of like a fingerprint for data. If you have a good cryptographic hash algorithm, you pipe some data into that, and you come out with a little, technically it's an integer, but we usually represent it as sort of a string of letters and stuff, but you come out with a hash, and if you just were to change one thing, suppose you had a 500-page book in here, and you were to like remove one period, you come out with a totally different hash if you pipe that data through the hash algorithm. There's some other characteristics of good cryptographic hashes, like you shouldn't be able to tell from the hash what was put in. There's no clues for going backwards, and low chances of collision, like you don't feed things in and come out with the same kinds of hashes and have collisions there. So a hash is like a fingerprint to uniquely identify some data. So many people know what a hash table is. It's just a key value store where you look up using a key to retrieve certain values. In this case, the key is the hash. So it's that cryptographic hash, that fingerprint for the data that you use to retrieve values from the hash table. Distributed hash table is spread across many machines. It's not just in one machine. So some of the kinds of systems that use distributed hash tables are like BitTorrent and a lot of the file sharing platforms that you may be familiar with.
How many of you have used BitTorrent? You're all going to jail.
We're filming this now. The distributed hash table technology is actually a lot more mature than blockchain technology. It's been around longer and has a lot of different variants. And one of the nice things about this is that we already know how to shard distributed hash tables. And so far, we haven't really successfully sharded blockchains. So what that means is when you publish something to the DHT, everybody doesn't have to hold it. If you have, I'm going to be using Twitter as an example a bunch of times tonight because Holochain, when you download Holochain, it actually comes with a peer-to-peer Twitter called Clutter, which may have to do with my relationship to Twitter. But it's also a name for a flock of cats. It's called a clutter or clouder. And so we have funny cat art and, it's a cat eating a bluebird as a kind of symbolic. Anyway, so in a Twitter example, suppose you have many, many millions of users, in fact, 330 million active users out here in DHT land. right, that tweet on the average of 1.1 times a day, right? So that would be a lot if you had that kind of churning of volume of activity in a blockchain. It would grow very quickly, right? Like who here knows what the current size of the Ethereum blockchain is? Yeah,
Over a terabyte.
it's over a terabyte. That's all we know.
I just read that yesterday, so it's probably not much.
1.1 terabytes. Yeah, they stopped publishing the size after about 600 gigabytes. Maybe it got embarrassing or something. But and now that, well, it doesn't matter. So if you had that volume, that Twitter volume, that volume of tweets, that blockchain would be growing incredibly fast, right? But if you have it on a DHT where you're dividing it up among everyone, then you just have what level of resilience, what level of redundancy that you're looking for. So for example, if you said, we always want to have 250 copies of every tweet online, then suppose you were running this app from your phone, we'll come back to that. Then you would be acquiring around 300 tweets a day, right? If I'm given the average of 1.1 tweets a day, and you're going to be storing basically 250 times your own 1.1 tweet average as a node that's holding redundant data. After about 6 months, that is the same as one 12 megapixel photo. How many of you have taken a 12 megapixel photo on your phone? Right, so it does not fill up so rapidly. And it creates this interesting effect of randomization in that the way that things go out to the DHT, if you write a new thing to the DHT and it gets sent out here, it goes to different nodes based on the hash. And because you can't predict what the hash is, that's another one of the things about hashes, is should be able to predict them. It's part of going backward, not being able to go backwards. And then the nodes that are near it using a nearness algorithm are the ones that have to store it. And there's a few funny things about our DHT in that it is validating DHT and a graphing or linking table as well. So what that means is that anything that gets stored to the DHT actually has to be validated before it can be made available to be served out. So if you have 250 copies that are going to be stored there, then you're going to have basically a random, unpredictable 250 people that are validating your tweet. And if it were a currency, they'd be validating your transaction. Yeah, Paul.
Are the validation rules custom to an application, or are they network-wide permanent?
They are custom to an application, and one of the things about that is that Holochain is not monolithic like blockchain. So Ethereum has all of the dApps and every transaction going through one blockchain. In Holochain, every app is a separate Holochain. It is its own private peer-to-peer encrypted network that there's no way for anybody on the outside of that to know that it even exists unless you advertise that it exists. Yeah, Matt.
We've got this running. I think if I go through that, it'll get us a bit of the why.
Okay.
That'll make some of the how have context to land in. That sound okay?
We get to switch back to Matt. David.
Can I just ask a randomization question?
Yeah.
So random has many meanings.
Yes.
So there's more than one kind of random, right?
Random in this sense means not predictable. It's deterministic, but not predictable.
So just for redundancy in a network. So we have an application spread across 120 cities, in different continents. This is randomly across the whole network, including some very hard places to get the data to, or as you said, it's local centric in terms of communication. It could be affected by how hard it is to communicate across.
Are we talking Arcade City?
Yeah, just as an example. Yeah.
So Arcade City, it would also depend on how you want to configure that. You may want to have different regions have their own apps. because you don't necessarily want to be synchronizing data across all the different collectives, right, or blocks. So it depends. One of the things that I'm hoping to get to.
Configurable is what you're saying.
Exactly.
All right,
So one of the things I'm
that's enough.
hoping to get to is, so there's these lines drawn around stuff. I'm hoping to get to what are the membranes involved in Holochain and how do you compose with them? So that's.
For your DHT, you said the keys were hashes?
So
what are the values?
yeah, these are, in a DHT, the address of everything is a hash, and the address of a node is the hash of its public key. So that when you take your public key and you hash it, that puts your address in the same address space as all the data, which is how we can measure nearness, because everything is in the same address space.
And the value is the content that generates that hash.
Right. If you say a get on a hash to the DHT, then you get back the value. So if I were to say get on the hash of your public key, then I get back your public key. If I were to say send a message to this hash of your public key, that's actually your network address. It would actually send your node, your computer, the message that I'm sending.
All right. You ready for the overview?
Paul?
This shouldn't be too hard of a question. I was just curious, you said each application has its own holochain. Would that include having its own DHT?
Yes, we'll go into that.
Are you going to talk about the bootstrap nodes for that as well? I'm curious.
We will talk about that at some point.
That'll come later, not in my talk, but we'll go into that. All right, Holochain. I'm Matt Schutte. Hello.
Should we turn off lights? Can
Yeah, can we turn this, whatever this light is on?
Tilt it up about 2 inches so it's towards the top.
Can you help with that? And then does anybody know where lights are for this? Yay, that's it. All right. A little too high. Let's drop it down.
Where it was before was fine. Yeah.
Good enough.
Just go
Okay,
ahead.
so a bit of history. 1989, Tim Berners-Lee created the World Wide Web, right? HTTP, HTML. When you look something up on the web, you look up that content by finding where it is physically located, right? You look up, it says go to this machine and then open this folder and then return this file, right? When you type in google.com, the DNS stuff resolves that to one of these IP addresses. The vision originally was that everyone's going to have a web server. I'm going to have documents on my computer. I'll be able to serve those out. You'll have documents on your computer. Great. I can do links to your documents. You can do links to my documents. This is a fully peer-to-peer system. This was a distributed system, at least in theory. But it turns out that running a web server sucks, right? If it happens to go down because you turned off your computer or a whole bunch of people got really excited about your thing and your computer suddenly wasn't able to handle all that traffic, you just took on a second job of being a web server maintainer. And not everybody was really excited about that. So pretty quickly, this new phase showed up where hosting companies started to emerge. And you would pay somebody else to host your website. The modern version of that, of course, is Amazon Web Services, right? Amazon having giant data centers that are serving out websites and applications for just about everybody. Phase 3, platforms start to emerge. You all remember this. It was like a decade ago, maybe a little more. MySpace and Facebook and all of that, where it wasn't just that they were taking care of the hosting. It was also that they were doing the website designs.
Squarespace. And
all of it,
Wix.
right? You just set it and forget it. I can go and use your space. And what does that system start to look like? Well, one, the web has become decentralized, not distributed. So there's a bunch of centers. There's several centers. And applications are mostly centralized, right? When I send you a message on Facebook, I don't send it to you. I send it to Facebook. And then Facebook sends it to you. And when you reply to Facebook, and they reply to me. This is a problem we're all familiar with, right? It's been in the headlines recently in terms of what they do with that data, how they manipulate us, et cetera. So why does it matter? Well, centralization actually undermines the founding goal of the internet, which was resilience. 1964, Paul Barron did this little drawing that you've all seen 1,000 times in his paper on centralized, decentralized, and distributed networks. And he was proposing that a distributed digital communications network would actually be failure tolerant. It would be capable of withstanding even an overwhelming nuclear attack. Whereas centralized or decentralized networks wouldn't have that same level of resilience, right? With a centralized network, you take out one spot and the entire system goes down. Holochain is a new way of running truly peer-to-peer applications, and they run entirely on the devices of the users themselves, on our phones, on our laptops, on our desktops. Now, the current version of Holochain doesn't run on phones yet. We're working on that. We're trying to get the beta, one of our beta versions to do that. But Holochain applications don't require any web servers. They don't require any mining. They don't require any cryptocurrency. That's not to say that you can't create cryptocurrencies. It's just that you don't have to have cryptocurrency in order to run a Holochain app. As we touched on a little earlier, this is not a platform. It's a pattern. How many of you have paid your HTML bill recently? Nobody, right? Why? Because that's not a platform. It's a pattern. It was a way of speaking. If you want to do angle bracket B, blah, 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 great. Other people will recognize that and show it as bold, right? That little string of text. Each app has its own members, its own storage, its own namespace, and its own validation rules. We're shifting from a world that treats applications as places to one that treats applications as grammars. Now, that's confusing at first, but how many of you have this experience? I go to Facebook and then I come back out, and I go to Uber and I come back out, and I go to Twitter and I come back out. How many of you feel pulled in 40 directions every day?
More, yeah.
Right? Why? It's because of this. The architecture is the architecture of applications as digital places that we go to. We're shifting that. We're turning it on its head. We're treating applications as grammars. What is a grammar? Well, information is always in form. Information. But we only experience information when we can experience transformation. That sounds super meta, right? But literally right now, I'm producing sound waves, and you have an eardrum, and that eardrum is going, it's literally changing shape. The fact that your body changed shape enabled you to experience meaningful information. If you are deaf, you might be able to go to a nightclub and feel, right? You can feel those sound waves. But sound waves that are of the level of me speaking, you might not be able to feel, at least not with a level of sensitivity that enabled you to extract meaning. So we only experience information when we experience transformation. If we're able to receive, if you can express information of a particular form, so I'm producing sound waves, and someone else can receive information of that form, you're receiving sound waves, you are being transformed by sound waves, then we have a shared grammar. We have a way of expressing and receiving meaningful information, right? So, coming back to this, decentralized, decentralized, distributed networks. What are these? They're all networks. But we're interested in going beyond that. A network has agents speaking a shared protocol or set of protocols. Whether it's centralized, decentralized, or distributed, it's me whispering something in his ear and him whispering that thing in his ear, and so on and so forth. But an ecosystem is more interesting. Can I get 3 volunteers real quick? 1, 2, 3. Can I get you guys to stand up? You can stay there. Stand up. Great. You're going to look at me. Everyone else, close your eyes. Okay, my 3 volunteers. How many fingers was I holding up? Say it at the same time. 1, 2, 3. How many? 2. Okay, everybody else, you can open your eyes. How many fingers was I holding up? 2. How do you know? Yeah, there was 3 different people there with some odd collusion stuff, so you feel like you trust it. Okay. What did they do? They transformed light information. They could see, because their eyes were open, they could see the light coming off of my fingers, into sound information, spoken in English. They bridged 2 protocols. You didn't have access to that light information because your eyes were closed, but you did have access to the sound information because you're not deaf. An ecosystem is more interesting than a network. In an ecosystem, agents bridge between protocols. and can transform signals on one carrier, light, into signals on another carrier, sound. Okay? So they transformed light into sound. Today, the internet puts applications at the center. You go to Facebook. Facebook is in the middle. We're turning the internet inside out. That's a quote by a friend of ours, Max knows her. It's actually how I met Arthur, a woman named Nancy Giordano, who started TEDx Austin.
And was one of the organizers of this event.
Yep. So we're turning the internet inside out by putting humans at the center, not applications. Anything that you can receive in one form, maybe you're using clutter, you're receiving 140 character meow is what we call tweets, right? You receive this meow, and you've got a little app that just says, hey, anytime I receive a meow from Arthur, I want to pull a random image from this library, and I want to write that text in Comic Sans, okay, onto that image, and I want to share that out into peer-to-peer Instagram. Suddenly, you are the bridge between these two spaces. People who aren't using clutter, who are just operating in this Instagram space, are able to benefit from the wisdom of Arthur Brock in Comic Sans form, right? This is really interesting because not only does it enable us to bridge between grammars, like we just talked about with the whole Twitter to Instagram thing, but it enables us to combine different applications for grammars. We're able to take signals that we receive from one community or grammar and signals that we receive from another and combine them together to create meta applications. Maybe a meta application that you are the only person on the planet who uses. Though on the back end, you're speaking in coherent ways with members of this community and members of this community. But you're getting the information that's relevant for you. This enables us to do innovation without all having to move in lockstep with one another. Right? We don't all have to adopt everything at exactly the same time. The next version update. If I'm running the same stuff with them and I go, yeah, but I want to pay attention to something new. You can pull in that information from that other source as well. We think that this is not only better for individuals, we think it's better for communities. In part because it enables communities to experiment and explore and learn from lived experience whether something seems to be working and helping them or not. If they try some new thing, hey, we did the Comic Sans thing, and we realized this helps me lose friends quickly, but that's kind of all it does, we might stop running that pattern. That's okay. That's part of the learning process. Okay. So I want to talk briefly about Holochain versus blockchain. Blockchain started out, it came from the cypherpunk community, right? And this was a bunch of folks who were really focused on freedom, but it was a specific form of freedom. It was freedom from constraint by others. It was literally, I want to be able to interact with this guy without that guy whacking me with a stick. That guy usually being played by El Government. Okay? Their goal essentially evolved into digital anonymous cash because they were worried that that guy, the government, would get inside of the community too. And so if he knows who I am, then he can still come whack me with a stick. Right? So how can we interact without having to know anything about one another? Even what you did the last 5 minutes, a day ago, 2 days ago. I want to know nothing of your history, and I want you to know nothing of my history, but I still want to be able to interact with you. And that set the goal for them of digital anonymous cash. The answer that they came up with, the solution was, everyone will keep track of everything. Right? You're all familiar with this, or many of you are global consensus. Every full node keeps track of every action that anyone has taken. Does that sound particularly efficient? No, it has major costs, right? It's not that it's evil, but it has real costs. What are those costs? Well, the costs of global consensus is that it's really bad at scaling, it's really expensive, and it's very slow. If your entire community can only move forward one step at a time, all together now, everybody step forward with your right foot, right? That's gonna suck. You're not gonna be able to learn very quickly. You're not gonna be able to move very quickly. So yes, it helped them solve that one problem, but it has some costs. We had a slightly different goal. And as a result, we created a slightly different architecture. Our goal was also freedom. But it was freedom to constrain ourselves. From our perspective, I should be able to enter into a game with all the folks in this room without having to have any one party serve as referee. We should be able to enter into a game and play that game together without needing to rely on somebody else. It's a different kind of freedom, right? It's not freedom from constraint, it's freedom to constrain. And to be able to feel like we're comfortable in that we can trust that this game is going to get played in accordance with the rules that we set up. So Art had mentioned a card game earlier. How many of you have played card games in your life? How many of you have played card games at home with friends? And how many of you hired a referee for that card game? Right. We know how to do this already. What happens if somebody tries to pick up a card when it's not their turn? Yeah, somebody else in the hip goes, what are you doing, man? It's Billy's turn.
Hit him with a stick.
You hit him with a stick. That's right. That's right. And when you call them out, when you say, hey, what are you doing? You're doing two things. You're both signaling to them, hey, stop. So you're taking direct action. And you're signaling to the others, hey, pay attention here. Something's going on. That's the way that we handle failures in a card game amongst friends. Well, if you want to play this game and I want to play this game, we think we shouldn't have anybody else involved. And that pattern is what enables it. We call this mutual sovereignty. That if you want to play this and I want to play this way, great. That should be all that's required. We shouldn't need somebody else. You can think of this pattern as an immune system response. An immune system response. We're not doing global consensus. We're using an immune system response. This is how our bodies handle threats as well. When you have some sort of infection starting to arise in your body, one of your cells might notice something's going on there. And as soon as one participant notices a problem, they do two things. One, they move into action. And two, they notify others. Right? They send out some signals. Hey, there's a problem over here. And they move to try to sequester the threat. And when some other cell receives that signal, it goes, oh, shoot, okay. And it comes over, and it says, oh, there is a threat here. And it notifies others and moves to sequester the threat. This is the process that distributed systems use for handling threats. Progressive trust. There's a guy named Christopher Allen, who's a friend of a few of us in the room. He's most famous for co-authoring the SSL standard, the most widely used security protocol in the world. And progressive trust is basically how trust actually gets created in the real world. Simple example, you walk into a bar, you're taking a risk right there. Okay. You see the pretty girl at the bar, you make eye contact, you're definitely taking a risk. She may have a giant boyfriend, you don't know, right? She makes eye contact, she turns away, she looks back again, ooh, she's taking a risk. Hey, can I buy you a drink? Sure, I'll buy a drink. This guy could be ghosting me, right? Like, over and over, you start taking risks, and as you make yourself vulnerable and see how that plays out, the other party is also making themselves vulnerable and seeing how it plays out. And together, you are gaining a better understanding of the terrain. You're building up your familiarity with, okay, what is this situation? You're building up literally your situational awareness. And so you're changing your capacity to make the next decision, take the next risk. Oftentimes, as part of this trust-generating dance, we will pull others into our relationships. Right? You go and introduce her to your mom. That's a big risk. Why? Well, because if it doesn't work out, you know for the next 6 months, your mom's like, what happened to that pretty brunette girl? Where did she was so sweet. Oh, Mom. Okay? When you sign a contract, you're pulling a whole set of institutions into that relationship. You're pulling the potential for a lawsuit, or if you don't abide by the court's decision, prison time, right? If I make myself more vulnerable, it makes it easier for you to make yourself more vulnerable. This is the trust dance that we regularly engage in. You're familiar with it from your daily life. This is how we do trust-generating dances. mating rituals, job applications. When you enter into a job application, you bring your resume. What is that? Well, that's giving them information about different parts of your past. What are the communities that you have participated in? That does a few things. One, it gives them more information about what you might be capable of. But two, it gives them a place to go complain if you show up poorly here, right? If they found out, yes, he was part of these communities, et cetera, and then later you screw them over, that's going to cost you. Because they've got recourse. They have a place to go make you feel the hurt also. If my cost significantly outweighs any benefit that I would gain, you can be more confident that I will behave well. It's just simple cost-benefit stuff, right? Blockchain's been making use of this type of logic for a while, but they're doing it all within the context of single games. Single games because they have no history. We were trying to get to anonymity, so I'm not able to know anything about your past, so you're not able to put anything else in at risk. You're not putting any more skin in the game. But that's not how we do things in the real world. We make use of multiple games. But we don't force you to bring portions of your history in. You get to decide, yeah, you know what? I want to enter into this relationship. Maybe I'll bring a couple of things from my past into this that will help make me vulnerable in ways that will make them more comfortable making themselves vulnerable. Enabling them to enter into this relationship and play this game with me. This is how we do trust generation. You don't need real-world identity to do this. They don't need to know what your actual body is. But you do need some level of pseudonymity, meaning you have to be able to show up in some way and put something at stake so they go, yeah, okay, I'm willing to rely on this. If you're anonymous, you probably get shoved all the way back, or could get shoved all the way back to everybody has to keep track of everything. You're not able to create safe spaces within which people can take specific risks. So you don't need real-world ID, you just need some amount of correlation. And it's the amount that's relevant to that situation. So in this way, Holochain is not trying to create trustless applications. We're trying to create trust-generating social spaces. Holochain combines tech from 3 established projects. I'm going to barely touch on this, and Arthur's going to go into a bunch more detail. In order to create a peer-to-peer application framework. The first is tamper-resistant logs from blockchain. As he mentioned, a hash is just a mathematical function. A hash function, an addition function, you have 3 and 5, and you put it into this addition function, and it spits out 8. Multiplication function, you have 3 and 5, you put it in, it spits out 15. Well, a hash function, you have 3 and 5, and it spits out this fixed length cryptographic hash. And the weird thing about them is visible to everybody else that you changed it, and it's visible where you changed it. Oh, these all matched. This one's different. Okay, that's where he made the change. That's where he tried to tell a lie. We're using the efficient shared storage architecture that BitTorrent uses. We touched on this earlier, DHTs, or distributed hash tables. And we're using what I refer to as the agent-centric identity architecture that Git uses, meaning there is no one global code base in Git. Git is the most widely used software for doing collaborative software development. It's a version control system. It basically works like track changes with Microsoft Word documents. You guys remember track changes? Like you send somebody something, it's green if they added new content to your contract and red with a slash through it if they deleted something. That's all Git is. But when somebody suggests a change, they sign that suggestion, and it doesn't magically become truth. You have to go, yeah, I'll accept that, and also sign it. You have to use your cryptographic signature to accept that change to your local code base. In our system, that would be to accept that change to your local source chain. So those 3 things, we take those, we combine them together. We'll go into a bunch more detail about the tech. To learn more, holochain.org. Thank you.
take some questions?
Yeah, questions? Yeah.
I just have one. What is the cost of a Holochain? Right now, say if I come to you and you say I'm gonna sell you a Holo for $200, like $200, and you walk away with it.
Yeah.
Well, this is your community. You know, right? But if you can just, if I come in here, you don't know me. I claim whoever I am, right? I take $5 from me, I walk away, and I send them a different version of me. Take another $5 from you, and I slowly destroy your community.
Sure.
What's
That community would have a pretty poor membrane in that case, if they were just letting anybody show up and print money out of thin air. Right? That's probably not how they would set up their rules. Okay? Generally, this is not how the world works. We don't have strangers come in and we go, sure, I'll make myself memorable to you. We wait until somebody demonstrates capacity or credibility. They have to show up and give first, and establish credibility first before others start relying on them. The stranger danger is the technical term. But that's the basic gist. But you're talking about Sybil attacks and things like that. This is an application-dependent problem. So Holochain, again, is a pattern, the way of building apps. There is no cost for creating an identity. But the cost for gaining access to some opportunity, that's going to be defined by the members of that community. You may have to put money in an escrow account. You may have to show up with some validation from a specific other community saying that you're a real good guy, or that you know how to practice medicine, or something else. Right? That's a context-specific thing, because in each application, people are deciding to make themselves vulnerable to one another in very specific ways, right? And so they're going to also make use of specific criteria to demand of one another so that they can create what they feel is a safe space so they can take those risks. So one or two other questions, yeah.
So like in determining like a level of trust, so to speak, like would each community generate its own trust in like that context? So when you were saying like bring in identity from another community in order to represent this community, would be the way that like I guess it would be like trying to figure out how those communities would actually communicate.
So again, everything bridges through agents, right? So the simple version is these guys said nice things about me in Arcade City. I'm a driver. I've got lots of people said good things about my driving in Arcade City. I want to start driving in some other community. I'm going to take this stuff over here and I'm going to sign that I am this other guy. In this app, I'm a completely different guy, right? But I'll sign a statement sort of saying, yep, same guy here, and look at all the nice things these folks have said about me. And when when this guy then, this identity that I'm using, shares that into this application space and says, hey, look at this. These folks have to have some way of going back and checking that. They have to have some relationship. There needs to be some open API. There's something there. We think that's okay. That's actually how the real world works. Reputation is not about absolute certainty. No, it's about bridging social relationships. It's about, I know those guys. I trust those guys. Oh, they said something nice about you? Okay, I'll believe that you're probably reliable. Yeah.
Yeah, can you give some high-level applications for this tech, and also like the coin? Like why does the coin have value, and what does it do in the ecosystem?
Sure. So high-level applications, any kind of social media, any kind of peer-to-peer sharing economy stuff, like those things all make sense real easy. I think in general, supply chain things become much easier when you have the participants able to speak a shared grammar but not have to use identical systems. The coin actually isn't for Holochain. Holochain doesn't have a currency. It's a pattern we're giving away to the world for free. We don't have a built-in business model for it. Arthur hates when I say that, by the way. But we don't have a built-in business model for Holochain. We're not charging for Holochain. We think it's really important that you could go and create some Slack-like app and use it with the members of your team, and we should never even have to know about it, let alone have some way to charge for it. But what we're doing is we're creating a first big flagship application that is a Holochain app, but it's also designed to be a service application that other Holochain apps can make use of. And the service that it provides is, hey, you're doing Arcade City, you're doing peer-to-peer ride sharing, or you're doing peer-to-peer Airbnb, great. You love that people can rent your rooms and that it works exactly the way you want it to work. But you don't only want to rent rooms to early geeky tech adopters? You would like anybody to be able to book a room?
Meaning who are running Holochain because they've installed some next-gen crypto app.
Yeah.
Like,
So HoloHost, the first big app, basically enables the members of your community to put up their hand and go, yeah, I'll make use of some of the spare capacity on my laptop or desktop to serve out websites to ordinary folks. So that when they type ourbnb.coop, sometimes that hits my machine. I reach into the peer-to-peer app and pull back the photos and the descriptions and the prices for places to stay in Austin and package that up as a web page and send it to them. And when I do that, when my machine does that work, the developer of that application pays me for the web hosting that I'm doing, just like today they pay Amazon Web Services. HoloFuel, the currency that we've designed, is a really efficient currency. Our accounting costs are less than a penny, which makes it so you can do payments that are worth a penny or less. If you have 20 cents in accounting costs, it doesn't make sense to send somebody a penny, right? It's also a crypto accounting system that can handle millions, or we think billions, of simultaneous transactions because it's actually a distributed system. We're not doing global consensus, so we don't have some bottleneck that everybody has to come into agreement around. So that payments infrastructure and the hosting, the routing infrastructure is what HoloHost does. HoloFuel is the currency that's used for doing those payments. That's our cryptocurrency. More questions? Yes and yes.
Sounds like you have kind of a trust graph inside of the system for watching whether or not somebody's credible and that trust is built over time. Is that accurate?
Within a particular community.
Okay, so is there a scaling limit on how large a community can get before it's no longer feasible to keep track of everybody? You're getting introduced to new people so frequently because the community is so large, it doesn't work anymore?
It depends on what that community is focused on. It depends on the currency systems that they design for making people accountable, right? If you have to put $1,000 in and you're only able to do one transaction a day and your transaction is only $5 max, right? You've got all this money sitting in your escrow. Yeah, you could screw somebody over, but you're about to lose that $1,000, right?
Sounds a little bit like proof of stake, right?
That would be, that's a specific approach. You could also have that not be cash, but be reputation from that it took a long time for you to build up.
Can I just jump in on a
Yeah.
couple things? Because actually back to your first question, let's give concrete examples because you're also asking about concrete apps. So there's already about 40 or 50 apps built on Holochain. There's chess apps and Battleship and Twitter and Slack and a whole bunch of core service apps
Wikis,
that we've built.
peer-to-peer
There's
wikis.
2 different wikis built on it. There's a whole bunch of core service apps that we've built because we know developers are going to want them, like for key management and identity management and things like that that are not built into Holochain. They are apps that run on top of Holochain that you can choose to use. So for example, back to your original question about what does it cost to create an identity? I mean, what does it cost to generate a key? Is the answer to that question. It's not very much computing power to generate a key. And then the question is then, in that application, what are the validation rules they have when you try to share that key to the DHT? Because that's how the membrane works. So if it's a Slack team, for example, when a new person tries to join, it may be that they have to have an invitation code, right? And that invitation code has to already have been listed out here so that other people can validate, oh yeah, this person was invited. They're not just crashing the party, right? And that may be all that's required. So what's the cost of that? Tiny, right? If it's Twitter, maybe you allow people to the party, and you don't need an invitation code because there's a pretty low cost of Sybil's breeding there, but there's some cost of Sybil's breeding there. So maybe you do require some kind of whatever you want, frankly, like proof of work, or you could do proof of stake, or you could just do social triangulation. You can say 3 other people vouch for that, or whatever it is. Like it really is configured for the app, and literally it is the validation rules for registering your public key. That's how the membrane is managed. It's all pretty straightforward, when it comes to doing it.
Yeah, so like in blockchain, I can do a one-to-one transaction, 100% guarantee will happen. We're not building that. We're not worried about it for one-to-one transaction fails. We're trying to build a community that will build a trust system that will work long term. Is that what you're saying? Was that the middle system where I can send you Ether, I know it happened. As opposed to I can maybe in a whatever hollow app, if it's built badly, it might collapse or they might rethink it. So there's not that one-to-one.
Yeah, we don't promise that every app will be perfect because people will write whatever code they do. And I'm going to make a somewhat bold statement if there are blockchain maximalists in the room, but I haven't yet seen a problem that blockchain solves that you can't solve more efficiently on Holochain, but you have to make some design changes to make that work. You can't just translate it over one-to-one because blockchain is doing token-centric computing, and therefore you have to have consensus on what tokens exist and how that inventory of tokens is changing, and in what order those changes happen, right? When you have an age-centric thing, you are making the changes at the state changes of each individual. And so you're validating that they changed that state. So correctly, that was a valid state change for them to make. So what I mean by that is if you're implementing a currency on Holochain, if you want to build your own consensus mechanism, you could do token-centric approach. We would recommend that you do an agent-centric approach, which is also super familiar to us. It's just double entry accounting, right? It's that agent A over here, we have an account for person A, and they have a chain over here for person B. And when they want to do a transaction, they construct the transaction through some node-to-node messages, and then once they've agreed to it, they each sign it to their chains, and they give the header to the counterparty as proof of their signature, and then it gets published to the DHT. But it shows that I have your signature on this, you have my signature on this. I can't change it without breaking your signature. You can't change it without breaking mine. And the software automatically, my software validates your chain and makes sure that you've got no fraudulent shit going on in your history, right? And your software validates my chain and makes sure that there's nothing in my history, that I'm actually in a valid state. And what a state means in this scenario is we have a series of pluses and minuses, pretty simple math. What did I spend? What did I receive? You just fast forward through that, checking signatures, checking the counter signatures as you do, as you go through, and that gives you my current balance. If I try to spend credits I don't have, that would be an invalid state change, right? And so it's pretty easy to validate. And the other thing about it, I know that some of you are also probably worried when Matthew says no global consensus. But in this scenario, I mean, what the primary purpose of global consensus is establishing order, is establishing sequence of events, a timeline, right? In fact, one of the things that the original Bitcoin paper referred to was that it was creating a global clock, right? Like in the actual proof of work on the hashes, on the blocks. So you don't have any questions of order. If we have agent B doing this transaction, which is this transaction with agent A, we know exactly what order that state change happened to everybody whose states changed. We don't need to know what order that was relative to C, D, or E, because their states didn't change. And we don't need their consensus to do it. We can validate each other's things, we can write it to our chain, then we share it. And this is the part where Matthew was talking about some of the vulnerability, the taking the risk or whatever. We've written something immutably to our chain, signed it, publish it. If we cheated, then the nodes out here can detect that, mobilize, take action. What that's called in Holochain is you create a warrant. Since every interaction with the DHT, actually every interaction with the network at all, is signed by your local keys, if you have done some illegal move, some illegal transformation, you tried to double spend, you tried to, whatever, and we can get into more detail about how that would actually work on a currency. But if you do an illegal action out here, you've just signed it. You just cryptographically signed the evidence against you, right? And all they have to do is take that evidence, they bundle it in a wrapper called a warrant, and they say, hey, this person's cheating. And they circulate the warrant, and everybody uses their own copy of the code, which we call DNA, by the way. Everybody runs their own DNA to see, is the person creating the warrant telling the truth, or was the person, reporting the stuff? Which person is cheating here? Which person is telling the truth? And everybody can make their own decision about it.
And it's pretty clear because they check the rules and they go, yep, that's more than 140 characters. Yeah, he signed it saying it was valid. It's definitely not. Okay, he's cheating. I want to actually touch on one other thing with your point, though. Often folks coming out of the blockchain space go, but surely blockchain is more secure. This is a bullshit, use a technical term there, bullshit argument that treats security as if it's one dimension. In life, there is all sorts of risk. One risk might be double spend. Another risk might be, I submitted it to the network, but some fucking CryptoKitties game came on, and my transaction never went through, and I wasn't able to buy and take advantage of this arbitrage thing that I was trying to do. A delayed purchase, that's a risk, right? There's also risks that have nothing to do with the chain. Yeah, he said that I was going to get this thing, but then when I showed up, there was nobody there, right? So our ability to manage risk stretches way beyond double spend. And our take on it is communities need the capacity to create the rule sets that give them the best chance of handling the kinds of risks that they are taking in their context. Whether that has to do with a double spend, or making sure this transaction goes through, or making sure that you're going to pick your kid up on time so I'm not late to my party tonight. Yeah, Barry.
So then why are you calling them membranes and not rule sets?
There's both.
What's the difference?
The membrane actually has to do with, all right, so
who gets to play?
Yeah. So first of all, I distinguish privacy distinct from secrecy. We typically don't have a lot of agreement about this, but if we go back to the poker game, there's who's allowed to sit at the table and play. That I consider privacy. Who's allowed to come into the room, that's another level of privacy, right? Whether a card is dealt face up or face down, right? The card's face down, the content of the card is secret. That's secrecy. Now, interestingly, in most of these card games, the fact that a card was dealt is important information in and of its own, right? If I'm turning in 3 cards in 5-card draw, that tells everybody something. They need to know that I'm turning in 3 cards. If I'm turning in 1 card, that tells them something else, right? The content of the card is still secret, but the action of the play was visible. And so there's different membranes. And when I mentioned earlier that I'd like to get to the point that we can compose with the different types of membranes, that actually has to do with a really concrete technical example. In the Slack app, there's a membrane around the team, right, where he said you might have to have an invitation code to join, right? So that's one membrane. That's an encrypted peer-to-peer network of communications. You can't interact with that network without having your address having been validated on the network, and without having the DNA that they're actually using to play by. That's the rules that they're playing by.
And to make that visible, if you were somebody on the internet who saw that traffic go by, you could see it, but it's unintelligible to you because it's encrypted in a way that you can't read. It'd be like being deaf, right? You just happen to be deaf to that particular form of information.
And so the DNA is the Genesis entry of every person's chain is the rules they're playing by in this space. Second entry, there's 2 Genesis entry in every person's chain. The second Genesis entry is your identity, which is where you identify your signing key, public key, that type of stuff. And that's what the validation on this entry is what determines whether you've entered that membrane or not. So there's membranes and there's rules. Validation rules are part of the code, part of the DNA, but the architecture of Holochain has different membranes. So, sorry, the Slack example I was starting, there's a membrane around joining the Slack team. Public channels, you guys have all used Slack, public channels, private channels, direct messages, right? Public channels make a lot of sense because you can just write things to the DHT. Anybody could join a channel later, they could find the chats on the DHT. It's public in this context, public within that outer membrane. Direct messages make a lot of sense, right? We could have two nodes sending directly to each other, and if they want to record the history, they're recorded as private entries to their chain. We didn't talk about that, but you can have different entry types, public and private entry types that you're recording to your chain. And so that makes sense. What doesn't make sense is the private channels part. That doesn't map with one of Holochain's membranes built in. And this is the kind of thing that blockchain does here is encryption. But encryption doesn't generally work the way that you want. If what you want is a place where you can add people later and they'll have access to the things that have been in this channel, or you can kick people out and they lose access to the things that are in that channel, well, once you've given somebody an encryption key, you can't really take it back. And if you take the approach instead of encrypting for each individual, then you can invite somebody new in and have them have access to the old content. So that approach doesn't particularly map well. So in Holochain, what we do is we bridge to another little app. Here's, if this is the Slack app, which is actually called HoloChat at the moment, we bridge to another app, literally called Private Channel, right? And then we have a new membrane, that outer membrane, we have a new membrane that we can bridge that private channel to. And so now, this is what I mean by composing with membranes. And that's the difference between membranes and rules. There's a different set of rules in the private channel subset, actually. And we have a bunch of questions. Back there, yeah.
If you go into the warrant stuff a lot deeper, then you can ask this question. But just for the Slack example, like, is the warrant issued after everyone sees the Slack message or before?
You have to, what you do with a warrant is it's an envelope kind of that you wrap around an action that somebody has taken. So they have to have already taken that action.
So it's already observed by the.
Yeah,
someone.
By particularly you, if you're generating the warrant. A way that I talked about this at Voice and Exit was, I feel like blockchain is sort of saying, if you don't make sure everybody is driving inside concrete barriers to stay in their lane, then you can't trust the system. Where we're like, actually, you can just have painted lines, and we snap a photo, and then everybody says, no, you're not allowed on this road anymore. We're not going to drive with you anymore because you're like driving all over the place.
So you catch it before it corrupts the entire.
Well, the thing is that when you publish to the DHT, it's a monotonic DHT in that you can only add data, but that data can be classified in different ways. So if you publish an invalid entry, so there's valid entries, there's rejected entries, there's modified entries, and deleted entries, right? So you can delete an entry, but it doesn't actually go away. It just gets marked deleted. It gets put in the deleted bucket. So same thing happens if you publish an invalid entry, it gets marked as rejected. And then you have the trigger on that as to whether or not it issues a warrant, depending on the type of offense it is. Eric.
How would a warrant work in this way, maybe for an example in like Hollow Fuel? If I discovered a bad action I could do that for some reason benefits me, and I just made a whole bunch of accounts. For an example of risk management in Hollow Fuel, for instance.
In Holofuel, we are actually doing KYC. We're not doing necessarily full banking compliant KYC, although for hosts that want to cash out through reserve accounts, where we're actually interacting with national currencies with them, we are doing full banking compliant KYC because otherwise we can't interact with them through the national currencies. But we're actually doing at least some level of KYC.
Everybody know what KYC means?
Oh, sorry. Know your customer.
Thinking
Sorry, but you've been in this space for a while. So there's some level of identity validation that we're doing in Holofuel. We're not saying every currency needs to do that, but that's one of our Sybil proofing approaches, is that there's a cost to creating accounts and that you have to be able to generate some pretty convincing identities.
So Holofuel would not be anonymous in that way, because it would always be attached to a real estate.
Right, we're not trying to make Holofuel anonymous, but you could make more anonymous currencies, but then you have to have other Sybil proofing methods.
So when you say some level of KYC, could you speak to what those levels of KYC are essentially?
Not really, because we haven't fully decided, but it may be just a banking transaction. It may be, I don't know yet exactly what the level of KYCs are. That we know some things about what we're requiring of hosts, but for just a general user, I don't think we've actually set that bar yet. It'll be a lower bar than for hosts.
And so you'll be storing that privacy info, privacy policy for that?
We may not be storing that. One of the really fun things about Holochain and how easy it is to bridge apps is that we could use an outside verification service and just keep the record of it having been verified by them, signed by that service as the proof of it without having to actually keep your identity information. In fact, when I said that some of the core services that we
They'll do storage of that and meet requirements without you, and they can do a zero proof.
Yeah, I mean, one of the things that we've actually done is build some identity tools for GDPR compliance, general data protection regulations in Europe.
Today.
That, yeah, just went into effect today, right?
Yeah. Oh, wow. We got a bunch of emails.
Yeah, exactly.
Are we passing on the privacy policy of they wouldn't store it, but they are storing it?
No, we're not going to take accountability for third parties.
So you use them to validate, but then it's kind of on them what they're.
Yeah, but it's probably not going to be we're not a very centralized oriented group. There's probably going to actually be a large array of third parties, like here's signing from your Estonia ID, here's signing from, like there may be a number of ways that you could validate. You just have to have validated by one of the acceptable ways. I mean,
If that third party was like Equifax, then all you're doing is you know that third party service help you find Google who that verifier can be. That's I just view that as a pretty important piece. Even though you wouldn't have liability, you're saying, okay, some third party's going to validate you, and they're probably going to save that info too.
sure, but maybe you weren't clear about what I was saying about not centralized, in that it will be up to you to choose from this list of third parties that we can recognize the validation.
Okay, so some options.
Yeah. Yeah, and the identity tools that we've built in basically mean you store your identity, and the convention we're trying to establish right from the outset, like you join a new Slack group, the Slack app says, here's a JSON blob of, a JSON object of the fields that we would like you to fill out in a profile. You actually take this into your identity app, your personas app, and build some mappings to your work persona or your home persona or your friends or your DJ persona or whatever it is, whatever lifestyle things you've got going on, to give them access to that data. That mapping is actually a private entry in your chain. And then you give them a capabilities token, which is a whole other thing we can talk about later. But you give them a capabilities token, which gives them access to that mapping, and you can revoke that token later. And so basically, you're still holding all of your information, your identity information, can change it in one place, and then you can give people little permissioned glimpses into it. Yeah.
You just mentioned Personas app.
Yeah.
Is that a feature of Holochain, or is it a separate app that exists?
At the moment, it's called Holo Vault, which I don't love, but if you want to look it up on GitHub, it's called Holo Vault. And one of the really fun things about it is that it's been built with UI testing separate from the thing itself, so you can actually run the UI without server side piece, so you can check it out if you want. There's a, yes, you've been trying to.
I guess I'm trying to figure out the way that you can verify random number generation between agents. So like, for instance, like if you have to high school or whatever, like
Yeah.
they have broken random iteration, and there's not really a deterministic way to tell
Right.
until after, like, so it's like, oh, your keys are having, or your
Yep.
hashes are having
Yep.
issues with collisions or whatever, so.
So one of the features, one of the tickets that we have under review and have had it under review for a long time, in fairness, is whether or not we need to basically have any network message, have a random number seed, kind of like some other things like Raft and another one that does that. Anyway, so that everybody starts with the same random number seed. I think the direction that we're meaning for that particular action that's being taken, any node validating it would have the same seed from which to take that random action. So again, it's not true random, it's just unpredictable beforehand, you know. It's still deterministic. But what I suspect we're gonna do, so the whole thing that sort of emerges in this Holochain space when you start to get what these creatures want to become, like what these applications want to become. They don't want to be big monolithic systems like Facebook that does a million different things. They kind of want to be an ecosystem of microservices. And so we will probably actually bridge to some like online quantum, you know, randomness generator thing, and you will have to actually have bridged that and logged that in the quantum randomness app, and you'll reference that entry by the hash of that entry or whatever, so that it's probably what's going to happen. We're probably not going to build that into the
So
network.
like, for instance, like there'd be an application that people run where everyone on that network has like a hardware random number. So.
But you don't have to have everyone, as long as somebody can service a request.
A reference one.
Yeah, and as long as you trust that, if you have, yeah. Yes.
Just a minute. I think
We're
we want to wrap up this section of the evening, but there's going to be an opportunity still over the next hour. So we're here till 9 o'clock. So so what kind of happens from here is that we've got a couple of different rooms and sessions that's available, and so there's going to be more time that can be spent in conversation and sort of engaging in these questions and those kinds of things. There's going to be some, we wanted to make it so that during Friday night it also gets hands-on, and there's two different types of hands-on that we wanted to introduce. One is if you're wanting to like really be on a track where you want to like learn how to code in Holochain, and that's like your focus, you really want to get into the command line and whatever, then I'm going to be doing stuff with that in the next hour, installing Holochain.
Who installed Holochain before coming? Ooh, nice.
Lots
All
of
right.
people. So that's really cool. So if you had issues, doing the session with me is also like a great place to go, because everybody's going to be following, going through the instructions that are on the tutorial or the developer website.
And of course, by the way, a new alpha release happened today that hasn't been tested by us yet. So we get to test that.
So that's going to be the one room where we're going to be working on installing Holochain via the command line and that kind of thing. Another path is working with Art and taking a different sort of angle of approach, which is to take a look at some of the rapid application development tools that have been created. There's something called a scaffold, which helps you start to think about how to build Holochain applications without having to get into the command line yet. So that's, but is to start to get kind of hands-on in understanding what Holochain is, how it actually functions on a computer, and how you would even think about designing applications. From the feedback that we got through the survey, we understand that quite a few people are just interested in how to design distributed applications. And so that's part of that. And then there's a third space, which will be kind of like, you don't have a computer with you, or you don't want to engage in a computer right now, and you just want to focus on conversation and connecting, then some of the Holochain team will stay at one of the tables and just kind of engage in conversation.
In time wasting.
But there's
For
actually
those of you who are
not
looking
so.
to not waste your time, I suggest you.
No, but there's real valid questions about some of the social patterns, like if you want to use this for governance, or you want that you can actually engage in useful conversations about. So how does this work? What would it be good for? How would it apply to my thing, even without getting on a computer?
And for all of your deep questions that were coming up, or your very specific questions which were coming up, like hopefully you're here for the weekend, in which case we can address them like at various points in the weekend, right?
But also, you can go to chat.holochain.org.
So one or two other things before we actually kind of take that that step is one, if you registered through the Eventbrite event and are here, then if you'd see Jared, because and just give him your name, because that's Jared back there.
If you haven't seen me or Eric earlier in the evening, but we did sign up on Eventbrite. We're just trying to figure out who might come tomorrow.
Yeah, so if you can see Jared, where are you going to be? Right there.
Can you just repeat the hours for tomorrow and the day after?
Yeah, so tomorrow it's 10 a.m. to 9 p.m.
Tomorrow's a long day.
Yeah.
But that's like still a humane hackathon.
We're not doing the 24, 48 hour.
So 10 a.m. to 9 p.m. tomorrow, and 11 a.m. to 6 p.m. on Sunday. Yeah. I guess it would be also that if you want to come for the weekend and you haven't registered through the Eventbrite, we'd appreciate it if you did, because because we'd like to include food as part of the event, and the costs on the Eventbrite ticket are really just for the sake of food.
And if you want to order food, we need your email in order to do that.
Yeah. So.
Do you know where the groups are happening?
That's right. Yeah. So.
Sorry,
Yeah.
Is there any structuring to the next couple of days? Or is it really just open?
Yeah, we can offer a little bit of context for that. And now might be the last time actually that we have the whole group like this, so it's probably a good moment to do that. So overall during the weekend, just to kind of set the big picture frame here, with Holochain, like any new technology, is unfamiliar, so there's a lot to learn and a lot to familiarize with. And so we treat like all the different kind of possible outcomes from this weekend as encouraged, whether you're just here to learn, and that's through conversations, or whether you're here because you want to build like a prototype or something, like you want to get coding. So we try to make it so that whatever kind of your motivation is for being here, that you can get what you want out of the weekend. So that said, catering to all of those different interests that people come with is a little bit of a balance. So so by having quite a few people on the team here, there's I think a lot of different ways that you can engage with us, more conversationally, or hands-on and from an application design perspective, with our getting kind of technical and almost from a theory first perspective with me, or not theory first, but like hands-on
from scratch.
Like coding, getting deep into the coding aspects of it.
Do you guys want to all raise your hands, like the whole?
Exactly, that's what I was going to do.
Yeah.
So who is somebody that you can come to talk about designing a problem or solution, designing the solution for a problem on Holochain? So.
Anders, can you stand?
Yeah, I would say Anders. So we can talk to you guys about it. You can no. I think you're not.
You're not framing the question.
Sorry. I'm trying to have people on the team raise their hand for who actually knows how to design solutions on Holochain. And okay, that's good. Now, what about for coding, for like actually building components of it? Let's stick with, let's say, the back end, like how to do the data integrity engine coding. A little bit, Anders. Daniel, wouldn't you?
Yeah, a little bit. Daniel?
Oh, yeah, sure. Yeah.
Daniel, this is not Daniel's first hackathon.
Yeah.
He went to like a week-long hackathon in London.
It was really cool. Should come to more of these.
You're back.
And then for UI stuff, how to actually build some of the things that interface with Holochain. I'm not going to raise my hand on that one.
Also, we probably have plenty of other user interface, and it's loosely coupled in terms of the back end and the front end. So any sort of skills that people bring with front end
Basically,
or
if you
user
can
interface
build,
development are useful.
if you can build web front ends that can make a JavaScript call to a WebSocket, then or to a local function.
Who got those skills?
Who's got those skills?
Hey.
All right.
All right.
Cool. So we got people hiding in
And
the back.
so to your question about structure for the weekend, then, if you have those specific questions, you can seek someone out. But we're going to hold throughout tomorrow. So big picture tomorrow is like, especially towards the start of the day and in the first hours, it's all about the learning and getting familiar and kind of trying things out and being hands-on. And then kind of later in the day, later in the afternoon, get into more like unstructured, open-ended project time where people are going to be in different spaces, whether you're working on an application or you're just kind of exploring and poking around the technology. And then, so that's like kind of Saturday night. And then like, of course, we officially end at 9, but some people end up coding and exploring, working further on things, and usually socializing somewhere on Saturday night too. And then on Sunday's really hands-on, less learning, more focusing, project-based stuff, and hopefully what we try to do is make it so that around 4 p.m. on Sunday we're getting together and we're sharing what we've been building, what we've been learning, coming back together, doing some presentations,
demos of anything built, just prototypes.
Prototypes and learnings. Anybody can share, sort of an open floor for sharing, and
There's a bit of celebration.
yeah, and a bit of celebrating at the end of the weekend. Does that answer your question and give people a good sense of it?
Yeah.
Yeah.
Before we get a lot more questions, should we just give the locations of the breakouts, because we can ask questions in the smaller groups?
Yeah.
Okay. Yeah.
Can we maybe go through the 3 options and show hands so we know what is the biggest room we can put those people here?
So I'm going to be using the rapid prototyping tools to jump in quickly to building a sample app. Maybe we'll take Unter, or maybe we'll take the Truth in Media app, or as an example, and we'll just like start mocking up something, and we'll jump very quickly to something using the RAD tools.
Who's into that? Raise your hand.
Cool.
Okay, so I'm going to be doing installing Holochain natively on your laptops, getting the command line tools installed, and also just kind of the very first step of sort of a hello world Holochain. Not going too far into it, but just so that you're getting an initial sense. So who wants to do that?
Raise them up.
Okay, awesome.
Okay.
And if you are lost souls,
Oh. You want to?
I can gab or answer questions or whatever in here.
Who wants more in-depth conversations with Matthew?
If not, I will go and sit in on the rad tools thing. So just to be really good.
Hands up.
All right, cool. I'll hang.
Okay. Okay, cool.
Damn you all.
So should the rad group stay here?
Yeah.
Okay.
You here, Matthew? Kitchen?
Yep. Kitchen. Where's the kitchen?
Around.
All right.
All the way around to the other side.
And the group with me,